Taking a look at maxima and minima. Recall that the maximum value of a quadratic or the minimum value of a quadratic is the y value of the vertex. So we're looking for vertices here. We're looking for the vertex of the graph. If the graph is opening upwards, then the vertex would be a minimum. If the graph is opening downwards, the vertex would be a maximum. So that's what we're looking for, is where that vertex is. This method we're going to learn is called complete the square. So finding maximum or minima, or let's complete the square. So complete the square. Let's go back to when we were expanding and factoring, and we looked at the concept of perfect square trinomials. In the case of expanding, if we had something like x minus 3 squared, again, we could write out x minus 3 times x minus 3, use FOIL and calculate it, but we said with a perfect square trinomial, it's easier to factor, or it's easier to expand, if we use the method that this middle term is the negative sign, because there's a negative sign here, this number times 2, and then the x from the first term. And the last term is this number squared. You will get the same result if you write this out twice and FOIL it out. But x squared, negative 3 squared, negative 3 times x times 2. That's where those three terms come from. So in general, and this I wrote this out with an h because it kind of looks like a vertex form, we take the h, and this middle term is negative because there's a negative sign there. If it was a positive sign there, we'd put a positive. But it's a negative sign there, we put a negative sign in the middle. 2 times h times x. The h times x, negative 3 and x, and then we doubled the 3. So here we have the h times the x, and we double it. That's that in general. And then the final term, that positive 9 came from negative 3 squared. Negative h squared, going to give us positive h squared. Two negatives multiply to make a positive. The general setup is there. That last term is always going to be positive. The middle term is plus or minus, depending on if we have a plus or minus in the middle there. Now in the case of factoring, so we can take this same concept, we can reverse it. And in the case of x squared minus 8x plus 16, is it a perfect square trinomial? Yes. 16, the square root of that is 4, or negative 4. And then negative 8, this half of that is negative 4. Negative 4 squared is 16. That's a perfect square trinomial. X minus 4 squared. We can quickly and easily factor that. In the case of the next portion here, x squared minus bx plus, and I left it blank because what is that term? What would we do and how would we write that out? Well, let's actually find this to make it a perfect square trinomial. So to get this middle term here, or to get this term here, this one that we would have after the x, it's going to be negative, again, because of the negative sign. But how do we get the 8 to the 4? We divide by 2. How do we get the b down here? We divide it by 2. b over 2. So there we have x minus b squared. So what's that final value? What's that c value there? Well, it's this value squared. Negative 4 squared. So negative b over 2 squared. We're going to get a positive, and we're going to get b squared over 4. So that's that final value, b squared over 4. Why are we doing this with all these weird letters and that combination? Because we're going to need to use this to complete the square later on. So we're going to use this concept. Specifically, this idea here is what we're going to be using. We're going to create our own perfect square trinomials. So keeping that concept there in mind, this is always the case. The plus or minus based on that number. And then this term here is half of this one, half the b. That's always the way we're going to have it with our completing the square questions. So in the concept of completing the square, we're making a perfect square trinomial with the first two terms. So we're actually ignoring this one here, and we're just going to worry about these two. So we're just worried about the x squared minus 8x. We're not worried about the 10 at the moment. So we're going to focus on these two to start. we're going to factor a from the first two terms. That's the first step every time, every time, every time. These are the steps every time. Factor a from the first two terms. What is a? It's 1. So there's no a to factor out. But what I'm going to do, regardless, is I'm going to write those first two terms in parentheses, just to give it separation. So we know we're working with the first two terms and putting them in parentheses. Now, the second step is to add and subtract the square of the coefficient of x. So if we're going to make this portion here, if we're going to finish that perfect square trinomial like we did up above, we need to take that negative 8, we need to divide it by 2, and square it. So, y equals half of 8 is 4. 4 squared is 16. Now we can't just add 16 to a question for no reason. So if I add 16, I also have to subtract 16 from the question. So I've added and subtracted 16. I have not technically made a change to the question. It is still the same equivalency. Add and subtracted 16 so that this portion here is now a perfect square trinomial. Now, multiply the fourth term of the bracket by a to move it out of the bracket. In our case here, we don't have an a, it's a 1. So we would multiply the fourth term, negative 16, and it's always going to be plus 16 minus. It's always going to be plus then a minus. Why? Because our perfect square trinomial's third term is always positive. So we multiply that by 1. We're just left with x squared minus 8x plus 16, and then outside the bracket minus 16 plus 10. Yes, you can multiply just one term within a bracket by the number outside. So that's here, we can take this portion, this perfect square trinomial, and change or factor it into the perfect square. So y equals x minus, because of that sign, and again we said half of that was 4, or that square rooted, it was 4. We made this perfect square trinomial ourselves. And then we simplify the last two terms. Negative 16 plus 10 is going to give us negative 6. There, we've converted a trinomial in standard form to a vertex form of the trinomial. Now, there are times that we will have an a value. There are times that you will get fractions and decimals, specifically halves and quarters, that you'll be working with in these. And that's the two decimal portions that you'll be working with, is halves and quarters. So here's an example of one that's going to include some halves, quarters, and decimal portions or fractional portions in there. So in this case here, we're going to start the same way. We're going to factor a from the first two terms. The first two terms being 3 and negative 9, so we're going to factor that out. 3 gets factored out. And if we factor 3 out of there, we're left with x squared. Negative 9 divided by 3, that's going to give us negative 3x plus 11. Again, we're only factoring out of the first two terms. The next step here says to add and subtract the square of the coefficient of x. So again, like above, where we took 8, divided it by 2, and squared it, we need to, and I should tweak that, I missed that half of 1/2 the coefficient of x. That fixes that. That looks better now. So we're going to half that 3. What's half of 3? 1.5. 1.5 or 3 over 2 squared. I'm going to write it as a fraction. You can use a decimal if you wish. Plus 3 over 2 squared. Minus 3 over 2 squared. Plus 11. I like doing it this way when I'm working with the fractions, because if you look at it, it's just this number over 2 squared. The same number over 2 squared. You just add and subtract that. Again, we're adding and subtracting the same thing, so we haven't changed the equivalency of the equation, but we're adding and subtracting that. This becomes a perfect square trinomial right here. Now, the next step says multiply the fourth term of the bracket by a to move it out of the bracket. So 3x squared minus 3x plus 3 over 2 squared. Close the bracket. We're multiplying the negative 3 over 2 squared by 3. And I'm leaving these fractions and squares here. Why? Because I'm going to simplify everything at the end. I find that way is a lot easier. Again, you can simplify these right away. You could turn this right into a decimal. Do 3 divided by 2 is 1.5. 1.5 times 1.5 is going to give you 2.25. You can go right away and do that. I'll even do that as an example on the side here if you want to take a look at that. Now, last step. Change or factor the perfect square trinomial. We've created this perfect square trinomial. Minus, because there's a minus sign there, 3 over 2. Add x squared. That's just an x, not an x squared. X minus 3 over 2 squared. That whole portion there, gone. We don't need to worry about it. We've already got it all cleaned up right here. Now we got to clean up this last portion. 3 over 2 squared. I'm going to turn that into a fraction. 3 over 2 squared is going to give me 9 over 4 plus 11. And then we'll just clean this all up. 3 over 2 squared. Multiplying fractions. 3 times 9 going to give me 27 over 4 plus, and I'll get a common denominator here, 44 over 4. Again, if you don't like fractions, I'll do this again with decimals. Rewrite that first part and clean that up. Negative 27 plus 44. Well, that's going to give me a, what do we got? 3, 4 is 17 over 4. So there we have it with fractions. Works out, again, I like it nice. It works out nice with these perfect square portions because, again, you can just pop that 3 on top over 2 squared, add and subtract that. That's the way I traditionally did it. However, you're uncomfortable with fractions. It looks like too much in the way of numbers. Let's convert these to decimals because your calculator often gives you decimals. So we can do the same question again. We use the decimal form of it. So we have 3x squared minus 9x plus 11. And factor out the 3. That's our a value. So the first part here is still going to be the same. Now, the next part, the decimal part. Okay, how do we get the decimals instead of the fractions? The same methodology is used. We're going to add and subtract. Half of 3 squared. Half of 3 is 1.5. 1.5 squared is 2.25 plus 2.25 minus 2.25 plus 11. Now, we need to multiply the fourth term by the a value, the 3. So we have 3x squared minus 3x plus 2.25. Multiplying 3 by negative 2.25, that's going to give me 3 times 2 is 6, and 6.75 minus 6.75 plus 11. And then finally, convert. We factor that perfect square trinomial. We're going to be left with x minus 1.5. That matches up with our 3 over 2 squared. Negative 6.75 minus 11, or sorry, plus 11 in this case. So we're going to get 4.25 plus 4.25, which is the same as 17 over 4. And that should have been a plus in that one there. My apologies for those of you that were confused and wondering why I didn't make that a plus. That is a plus. My mistake. We're in a class where you guys can yell at me that I did it wrong. So Both methods work. Is this one shorter? Yeah, it's got some decimals. Again, I like fractions. I think the fractions make sense more in the first little bit here. You see why that add and subtract portion matches up with the perfect square trinomial. Your choice on how you want to do these. They are a little more of a complex concept. It's probably one of the most complex concepts that we do work with in this course. Make sure you try some questions, you practice them, go over them once, go over them twice if you need to, understand that process until you start getting them. And hopefully, if you have any, you don't have too many questions, but if you do, again, send me a message online, Edsby, email, or during the live streams.